Hi, this is video 3. In this video, we're going to discuss the OpenSciEd norms and how to encourage student discourse. In video 1, we went over the anchoring phenomena about the cold cup. And then in video 2, the focus was kind of the big picture, looking at the storyline, how to navigate that. And we focused on the putting pieces together routine. And after video 2, the assignment was for you to compare like the questions you generated in the anchoring phenomena routine to what's covered in the unit, looking at the storyline, and to see when those questions that you came up with thinking as a student are going to be answered in the storyline. So this video is going to focus on the norms and how to encourage student discussion. We're going to start by looking at the norms document, and these are established in the first unit of each grade level, the 6th, 7th, and 8th grade. So they're not as emphasized as much in this second unit of the 6th grade. But before certain discussions or certain routines, you'll be prompted in the teacher's guide and in the Google slides or PowerPoint slides to have students like select a norm to focus on. So it's good to be kind of familiar and have these established at the beginning of the year. So the 4 main norms are being respectful, equitable, committed to our community, and moving our science thinking forward. So I want to kind of show an example of a teacher establishing those classroom norms in a kind of initial consensus model discussion. So this video is found on the OpenSciEd website. They have a couple examples from field test teachers. So these are good to watch, so you can kind of get an idea of the style of teaching. So
Writing's not that easy, but
Read it first. Let me see it, Liz. 5 in.
Start from the beginning.
One of the reasons we're sitting facing each other is because everyone's ideas are important here. All right? And you guys are noticing I'm not really giving you much information in this unit. Is that correct? So here's what I'm asking us to do now. I'm asking us to be listening to what other people are saying and be ready to respond to it. The first thing we're going to have people do today is present their models, their individual models that they were working on the last couple days. I've got a couple that I've selected, and I'm going to be projecting up here, and they're going to be sharing it. Who can read on the board the first bullet point? So I'm going to read this out loud. 5, go for it.
Listen as your classmates share their models. Are their models similar to yours or different from yours?
So as you're going to be sharing them, I really want you to think about what's similar and how they put that and what do they put that was different. You ready? You saw any?
No.
If you have it written down, read it.
I mean, I do. I just don't like it.
Why not?
Because,
Read it first. Let me see it, Liz. 5 in. 5 in. Read off here as well. Read. Okay.
doesn't make sense.
What is the copper's job in the speaker? What does it do?
I think that, what is the what's part? What's the job? The copper. So we're talking about the copper that actually makes up the wire. Does that have a job? I think that's a really important question. It's made out of copper, right? We noticed it was the same material on both speakers, right? Maybe there's something to that. Why do you think it's copper, by the way? Anyone have any? Does it have to be copper? I don't know. Like maybe we should test something like that, right? Okay, put that up there. in your mind, no one else had a question like that. So when you have something that no one else has, that's not something to be embarrassed about, Markel. That's something that like might push us in the right direction, right? So be proud of that.
So let's look back at the norms and kind of think about how that discussion went. So the teacher provided encouragement for the students to listen to each other. You know, that they're all kind of working to try to understand this together, and that everybody's ideas are important. And that last student in that clip, he was kind of hesitant to share his idea because it was different, but that teacher, you know, prodded him to speak up and got another student to read his question, and it prompted another student to wonder about the importance of copper. And now that student like feels valuable, like that his ideas matter, and his out of the box different questions can help determine the course that the class goes. So I thought that was a really good example of where the norms come in and how important they play in the anchoring phenomena routine and coming up with sharing your classroom models and sharing your driving question boards, and that it's important to hear from every student. So he did a great job modeling that. Another tool that can kind of help your students with discourse is this poster of communicating in scientific ways. And I like how it has these little kind of visuals and some sentence starters. You know, these are great to kind of cut out, you know, as on little like cards. You could laminate them, you could put them as like a little tabletop, post them in your classroom, and, you know, reference them and say, well, in this discussion, I think you guys should really focus on, you know, we're doing our initial trying to make sense of them all. Let's really focus on what we noticed and record and from watching this video. Or you know, it might be we're looking for evidence or needing to listen to each other and ask kind of deep questions. So these are all these different ways that we communicate scientifically. So this is a great resource to include in your instruction. Another resource that I find is really helpful when teaching an OpenSciEd unit is the Ambitious Science Teaching book, and they have a great website that has a lot of tools. So I wanted to highlight one. You know, coming up with like the classroom norms and stuff like is best done, I think, in a collaborative process. And I thought this was a great way to do it. So, so they had this kind of goal that we would respectfully disagree with an idea. And then the students came up with the prompts. So it's in their language. And there's a variety of different ways that they came up with about how to be disagreeing with an idea. And they had ideas for other prompts to use, like agreeing and adding on another person's idea, or asking a probing question for evidence, or asking a peer for clarification. Then they also had different kind of roles to put students in regards to, you know, student talk. And then here's a tool for scaffolding. Here's an example of a gotta have it checklist. So I just find that the tools for Ambitious Science Teaching website really helps support the OpenSciEd curriculum, and gives you some very specific tools to try so that your classroom can look like the one in the video where shy, hesitant students feel brave enough to share. It doesn't just happen overnight. It takes a lot of work. And so I thought that these tools will help you get there. And it's really helpful too that these like routines, like the putting pieces together routine, the anchoring phenomena routine, the navigation routine, they appear over and over and over again in the OpenSciEd units. So the students get a lot of practice. So even if it doesn't go great the first time, they're going to have practice in the next unit to do the anchoring phenomena. You're going to be doing the putting pieces together routine 3 different times in this unit. So you get opportunities to improve, and you'll really see your students grow over time in how they talk with each other. So those are some tools that you can use to help get students talking in a scientific way in your classroom. So between video 3 and 4, reflect on how you are going to use the OpenSciEd norms, where they fit into your classroom routines and expectations, and how are you going to support student discourse and inquiry in this unit. So answer that prompt, and then you'd start video 4, where we'll dig into the assessments, and I'll share some more resources about how to implement this unit.